Okay, so welcome back to the afternoon session of DSA. So I apologize, there is some background noise, but that's some guy supporting. For those who don't know, the local dialect here is saying, go DSA, go DSA. We'll go with that. So to start off this afternoon session, we have Eric Sodomka from Facebook. He has been with data science for quite a while now as a common and regular face of BSA. So he'll be talking about mechanism design, and an interesting thing about his presentations, he always has something to give. Previously, there were good books. Today, I don't know how we'll do it online, but welcome, Eric. Please take it away.
Thanks so much, Ernest. Yeah, we'll find a way to do something similar to what we've done in the past. So thanks, everyone, for taking the time to join me on this session. So this is actually sort of a combination of a few different talks. One is the tutorial on mechanism design, which I've given in past years. And in those past years, I've sort of given this motivating argument that we will soon be having some contest where you can sort of submit a proposal of how you could use mechanism design in practice to solve real world problems in your area. And we actually ran that contest. We had $150,000 in research grants. And so I'm also going to talk a bit about that as well. And many attendees, past attendees of DSA submitted to that. And I hope that you who are in attendance now submit next year when we run this. Hopefully we have the same, I don't know what the funding will look like, but hopefully it looks as much or more as this past year. So if you've been at these sessions in the past, you know that this mechanism design tutorial is a little bit different from the others. We don't have a Python notebook that we use, but it's very interactive. So we'll see how this works. But here's the first piece of interactivity, just to make sure that you're able to do it. Everyone answer in the chat to this question, including myself, if I can do it while I'm sharing screen. There we go. 2 plus 2 equals whatever you want. So let's just make sure that the point here is, one, make sure you know how to reply in the chat, because we're going to be asking questions, and if you aren't sort of actively thinking about the answers, I think the very easy thing to do, and I'm guilty of this myself, is just passively consuming. But if you actually try to engage and answer some of these questions, I think it will force you to think about it a little bit harder. And the only reason I say answer anything except for is because there should be no expectation that you are only answering if you know the right answer. Your reply is just to the panelists, and the idea is just to say what you're thinking might be the right answer. You do not have to answer correctly here. Just thinking through it will be helpful. All right, great. So we got a lot of good answers here. 10 in base 4, nice answer there. Okay, great. So thanks, everybody. So let's go back to the presentation then. Okay, so first of all, I should say that what I'm going to be presenting is the work of a lot of different people, many whom I met at Data Science Africa. Katie Bernhard, who was at DSA Accra last year in Ghana. Dina, who's on the leadership team of DSA, she helped organize a workshop around this very recently. And Bio from Data Science Nigeria, he also helped organize this workshop. So yeah, hopefully we can, some of you who are in attendance will be involved in the future. Okay, so basically I'm coming from an area, so I guess I should introduce myself first of all. So yeah, I'm Eric Sodomka. I'm from Facebook. I'm a research scientist on a team called Core Data Science. And there are many teams within Core Data Science, but the sort of subfield that I work on is called economics and computation. And specifically, I work in an area called mechanism design, and we'll get to that in a moment. But basically, you can think of this as it's the intersection of economics and computer science, as the name suggests. You can think of this as AI with multiple participants involved. So there are multiple agents, and these agents are behaving strategically in some way. And so we need to, in order to decide how to act, we need to be reasoning about how others in the system are going to act. That's sort of a very rough idea of what this field is, but we'll get into it once we get to the tutorial. So sort of the motivating question here is from the perspective of economics and computation. So this is a conference that happens every year, sort of the top tier conference in this field of economics and computer science. And so the question is, are we actually focusing our research community on the most important problems that we could be? Or another way of thinking about this is, do we actually have any blind spots where there are some areas where we could be applying the tools of economics and computer science, which you'll be learning about here, but actually we're just unaware of the problems that could be tackled. And I think this map sort of indicates that we definitely have blind spots in our research community. So what this is showing is at that conference, Economics and Computation, which just happened in July, this is showing the accepted papers by so each paper has a number of authors. Each author has typically one, sometimes more affiliations. And this is showing the countries of those author affiliations. So you see, the vast majority of the accepted papers at this conference are coming from the US, and it's really not even close to representative of the global population. And there were no accepted papers from the entire continent of Africa. And so, this seems very obvious to me that, we definitely have blind spots, and there are almost certainly both problems that could be tackled with the tools of economics and computer science that currently aren't, because those that are submitting and having papers accepted just are not aware of the problems. And there are also people that could really be contributing to this field who are maybe not yet familiar or new to the area. And so the purpose here is to sort of, fill in the map. So can we actually get expertise globally in this field of economics and computer science? So this is the main idea of what I've been, why I've been coming to DSA the past few years is I want to help connect established Econ CS, economics and computer science researchers, any aspiring Econ CS researchers who may be here and may be very established in some related field, as well as practitioners to work on real-world Econ CS problems for social good, and then in the process expand the Econ CS community. And that's really the key part here. Is the goal is not just to surface some problems and have this community work on them with no context, doing a very poor job at trying to solve these problems. Really, we want to bring you in attendance into the Econ CS community and make you a expert in this field, so that we have this new intersection of expertise where you are aware of problems in wherever you're from. You are aware of the problems in your local community, and you sort of are uniquely positioned to think about how you could use these tools of economics and computer science to tackle those problems. So what we had recently was this request for proposals that some in attendance submitted to. So this was basically $150,000 in funding. The funding came from Facebook, but this was donated to an organization called SIG Econ. So this is basically the chapter of ACM SIG that is focused on this field of economics and computer science. So applicants just had to submit a 2-page research proposal saying how they would use the techniques of economics and computation to help achieve some of the UN's Sustainable Development Goals. Specifically, the scope was applying this to a lower middle income country. And it was required that the principal investigator had to be from or reside in a lower middle income country. And ideally, the team would be interdisciplinary, consisting of practitioners, established, and aspiring researchers. So just to give you some idea of the selection criteria, because I hope that you do submit next year when we run this. So we're thinking about 3 key dimensions. So one is the likelihood of publication. If we actually fund this proposal, what are the odds that it will actually result in a research paper in the next 1 to 2 years? So that's number one. Second is, how likely is this actually to have some real world impact? And third is this actually diversifying the Econ CS community and leading us to this, these new intersections of technical and domain expertise? And we had sort of a number of standard dimensions that you might think about: readability, novelty, technical quality, but maybe a unique one was this latent relevance to the research community. So even if you didn't exactly hit on an Econ CS problem, if we thought there was potential for there to be an Econ CS problem, we accepted this as a poster as well. So we really wanted to get applicants engaging with the Econ CS community. And so we accepted as a poster at EC. We had a number of things we did to sort of help ensure we got quality submissions, and we definitely did. So we had a number of people from Econ CS give talks about success stories of how their research is actually taking some real world problem and applying the tools of economics and computation. For example, in the lower right corner there, you see Fei Feng talking about security games. So this is, we have some limited resources and we want to defend against some targets. And in Fei's case, this was defending against poachers of endangered species. So we have some security forces that are going to go on patrol looking for traps and snares that are trying to capture these endangered species. The question is, how can we decide on the routes for these patrol people to go on to minimize the loss of these endangered species? And so a number of people sort of had ideas from that of how security games, as they are called, could actually be applied to a real world problem. We had a number of different mentorship options, and those will still exist for those of you that are interested in submitting to this. So I'll get you connected to these different avenues if you would like to receive some mentorship if you want to submit next year. And this is what our submissions ended up looking like. So Africa was very nicely represented. Indeed, Uganda had a number of quality submissions. Tanzania, well, you can see the map there. Nigeria also had many submissions. So we had 58 total submissions. They covered 14 of the 17 UN Sustainable Development Goals. This came from 18 distinct lower middle income countries. Nearly 70% of all submissions were from Africa. Over 20% happened to come from Nigeria. So we accepted 20 submissions as finalists, 20 more as posters. And of those finalists, we ended up naming 8 of them as winners. And we only announced this at the workshop, who the winners were. We have not yet posted it. But for those that were not at the workshop, we will also announce the winners here before we actually post them to the website. So you get a nice sneak peek. So just to give you an idea, here are some of the example finalists and posters. So there was some work on how do we, we have some limited resource setting and we want to be applying COVID-19 tests, but how do we sort of optimally apply those tests? I mentioned security games. How do we use these security games to curb insurgency that is going on in Nigeria? How can we reduce information asymmetry for cashew nut farmers in Tanzania? So I should mention that those, actually the 3, so security games, information asymmetries and matching freshman students to universities in Ethiopia, all of those came from past DSA attendees who, going through this exact exercise that we're going through and will be going through, came up with the seeds of their idea that they ended up submitting and had an accepted poster or talk. So yeah, just further encouragement for those of you in attendance to, there are good examples to be following of people who were at DSA just like yourselves, ended up submitting some pretty compelling submissions. You can see the full list at gcec.org/winners. So let's just take a moment. If there are any attendees who did submit in the chat, could you please call out that you submitted and say what you submitted on? Just the title would be fine. So I see Daniel Mwebabze is here. I know he submitted. Just going down.
You can just raise your hand and we'll enable you to talk.
Perfect.
Eric, can you do that? Can you see the attendee?
Yes, yeah, great.
Is allowed to talk. Maybe you can moderate that on your side.
Yes, okay. So I just allowed Daniel or Mwebabze. Segun, let me allow you to talk if I can find you on here. Okay, Segun, if you would like to talk, I've just allowed you to. So feel free if you want to say what you submitted.
Hello, everyone.
Hello.
Hello, this is Shagun Ababa from Nigeria. My group submitted a proposal using security games to curb insecurity in Nigeria. The conference was a really eye-opener for every member of the group, and it was a fun. Thank you.
Excellent. Thanks so much for submitting.
Hi.
Okay, anyone else?
Hi.
Who's this?
Good evening, everyone. Yeah, this is Hallelujah Warinde. I submitted proposal using security game to curb insurgency in Nigeria, and I was able to make the poster presentation at the last conference.
Yes, and that was an excellent poster. So we have links to all the posters as well, so we can share those with you. Joyce, I see, is also here. She had a submission. And Mwebabze.
I'm not sure if you can hear me.
Yes.
Yeah, so I wanted to let the other, guys go first. Happy to be here. Hello, DSA. I miss you guys. Okay, the poster. Okay, the proposal. So I submitted something with Mark York from MIT, and we're looking at predicting creditworthiness using socio-knowledge, using some mechanisms, one wagering mechanism, and another truthful mechanism. So yeah, thank you.
Nice. Great submissions.
Hi,
and
everyone.
Joyce?
Hi everyone.
Hi,
Hi, DSA. So we submitted our proposal for expert in the loop advisory services for smallholder farmers in Uganda. And what we're basically doing is trying to find and build a machine learning model for localized recommendations to our smallholder farmers. And I participated both in EC and in the workshop at GCEC, and it was really good. Thank you.
Great, thanks so much. Okay, yeah, so there's some examples for those of you in attendance of some success stories, and I encourage you to follow their lead. And that's a subset of the many people from DSA who submitted some excellent submissions and presented at the workshop. Housing allocation in Kenya was another one. The list goes on, but you can see at gcec.org/winners, you can see all the finalists and posters. So that leads us to who the actual winners were of this. So we ended up giving funding. We had $150,000. We ended up giving funding to 8 of the finalists. And so this isn't on the website yet, so this is a semi-exclusive peek. Those who were at the workshop know, those who won know that they were winners, but we'll go through them right now. So first, full funding at $25,000 was the work that I mentioned on maximizing the benefits of an acutely limited number of COVID-19 tests in San Luis Potosi, Mexico. Second, at $20,000 funding was a submission from India by Smit Gade, targeting and allocative efficiency and vocational training, evidence from the Sweeney program for adolescent girls and young women in India. Then we have Mwebabze Daniel was one of the winners at $20,000 funding for the submission that he just mentioned towards creditworthiness, eliciting social knowledge for agricultural credit in the developing world. So congrats to Mwebabze and Mark York. Then we have afforestation incentive design for smallholding farmers in Uganda. So another submission from Uganda, $20,000 funding. Then we had using mobile money data to estimate household poverty and target credit service interventions in the Democratic Republic of Congo at $20,000. Then we had Joyce was also one of the winners. So expert in the loop recommender system using machine learning for localized agricultural advisory to smallholder farmers in a developing country. Then we had a submission from Romania reporting on online media activities, biased news inference algorithms at $10,000 funding. And then finally, we had a submission, Doing Better Well, designing a market for allocating donations. This was from Iran, as well as collaborators in, I believe it was Switzerland. So yeah, there were many more compelling submissions beyond these. And so if you are quick at adding things up, you may notice that this comes to 145,000, not 150,000. So with that remaining 5,000, we're using it to try to help others engage with the Econ CS community. So we're looking for ideas for those of you who may have submitted or been finalists, or might have some insights in, what are the bottlenecks right now that sort of keep you from being engaged with this community, submitting papers to EC, having them accepted at EC. Please talk to me afterwards. I would love to hear your ideas of how we can use this these remaining funds. Okay, so the whole point here is I hope this provides sufficient motivation that this is not, I'm not blowing smoke. This is not, I'm not just saying things that are not coming true here. These are people that attended DSA in the past, attended this tutorial, submitted a seed of an idea, and ended up winning one of these research grants. Of course, there were many other people who did not go through DSA and submitted, so this is not limited to DSA attendees. And there are a number of useful organizations that could also help with your submission. So if you are around, I think tomorrow, the Mechanism Design for Social Good group is going to be giving a talk. So I really encourage you to attend that talk as well, because they had a number of winning submissions, and they have a lot of support for helping you engage with this community. Okay, so with that, hopefully that is compelling enough reason to pay attention to this tutorial, which is the same tutorial that I've given in past years, slightly modified. So I should say typically we've had past attendees of the tutorial help with the tutorial, and really just for logistical reasons, I didn't get around to doing that. So those of you in attendance now who find this compelling, I really encourage you to, if you would like to be leading this tutorial next year, I very much encourage it. Just send me a message if you're interested. and I think it was nice last year having past attendees give this tutorial. Okay, and I should say this is based on lecture notes by Tim Roughgarden, who was at Stanford and is now at Columbia University. He's really one of the best lecturers I know in teaching giving an overview of mechanism design and all the tools that go along with it. So okay, with that we are finally getting to the tutorial. So we're going to start with a motivating problem, and here's where you're going to start using this chat as well. Okay, so I guess I had some further motivation on this RFP. Request for proposals. I think I've given sufficient motivation with this more recent request for proposals, but we've done this in past years, and Mwebabze was actually one of the winners for this as well. Okay, so let me start actually with, so as Ernest alluded to, we give away some prizes in this tutorial. So if you would like to be eligible, all you have to do is join this group, Mechanism Design at Data Science Africa. This is where we post, we'll make announcements about these sorts of contests that happen. There's a number of useful resources there if you want to learn more about mechanism design. So I'll leave this on for a minute. Just join this group. Anyone who newly joins this group is going to be eligible for this sort of mini contest that we'll have at the end of this tutorial, where we'll give away some online books and we'll give away some data for you to attend future versions of this conference or to put towards attending DSA. So I'll just give you a minute to join that group if you haven't already. And I'm going to look on my phone to see if people are actually joining. There we go. All right, so we have at least 3 people will be eligible for this contest. 4 people. All right, I'll give you another 30 seconds.
I've copied the URL in the chat in case people want to.
Oh, perfect. Thanks a lot, Ernest. All right, so join above group for prizes at end of tutorial. If you're already in the group, I guess feel free to remove yourself and add yourself again, because I'm only going to look at those who have recently joined the group. So if you want to game the system, talk about incentives, feel free to join and re-add yourself to the group. That is perfectly fine if you want to be eligible. Okay, so hopefully, that we'll, at the end of the tutorial, we'll revisit that. So here's the problem, and if you've seen, if you've been at past DSAs, you're probably very familiar with this at this point. So we'll have to pretend that we're all in the same room here for a moment. And I sort of come with, I know that attendees here at DSA are interested in data science and sort of related fields. And so I come with this big, let's just imagine, this big bag of books on data science and AI. And so here's some of the examples of some of the books I'm bringing. And there are, how many participants? So there are 39 participants right now, attendees of this talk. So let's say that I brought 39 books with me. And the question is, how am I actually going to decide who is going to get which of these books? So it's a resource allocation problem. I have these resources, these books, I need to decide who's going to get what books. And so that's going to be my question for you. How should I actually go about giving these books out? And I'm going to propose just to get the conversation started, a mechanism, we're going to call it, is some means of giving out these books. And I'm going to call this, this algorithm, you could also call it, is random assignment. So it's very simple. All I'm going to do is randomly order the attendees, so everyone gets a unique number, and then I'm going to randomly choose one of the remaining books and give that out to whoever's turn it is. So you could also just think of this as I'm randomly going up to someone, reaching into my bag. Oh, here you go. Here's your book. Hallelujah. Here's your book on computer vision. Shagun, here's your book on natural language processing. Oh, you don't care about that? That's too bad. That's your book that I randomly gave you. Here's your book, Alessandro, on AI. Here's your book, Andrew, on data science for beginners, and so on. Okay. So I think this is pretty clear, hopefully, what I'm proposing initially, randomly giving the books out. So the question, so now your neighbor is the chat. So discuss in the chat, do you have any complaints about this random assignment procedure? And can you come up with anything better? So enter in the chat any ideas you have. And again, 2 + 2 = 5. Remember, you may have entered that previously. There are no wrong answers here. Even if you enter a wrong answer, that is better than no answer. So I'm just going to give you some time to, really I encourage you to think about this deeply. I mean, as deeply as you can in a few minutes. Do you have any complaints about how we're giving these books out? Can you come up with anything better? So answer in the chat. This will be an awkward few minutes of silence, or feel free to raise your hand as well. But let's at least give everybody a couple minutes to think about this and actually, go through the process of writing something down. So, sort of forcing you to think about it yourself. Okay, so I'm going to start reading off things soon, but I want to give everyone a chance to really think about this. You will learn much better if you, even though it takes a little more effort, if you actually think about this, what are the complaints you have, and can you come up with anything better? Okay, great. I'm seeing a lot of people answering here, which is great. So let's try the hand raising if anyone wants to volunteer and sort of say it in their own words. If not, I can read off some of these answers, but just to get people involved. So let's start with this first question. Do you have any complaints about random assignment, just randomly giving out the books? And I've I set it up, the way that I described how I was giving out the books gives some pretty obvious clues about some possible complaints. So does anyone want to raise their hands, and I'll allow you to talk? Oh, good. Yeah. Mwebabze is raising his hand. Great. Let me see if I can. How do I allow Ernest? Maybe you can help. How do I allow him to talk?
Right. I think.
Allow to talk.
But he's
okay.
allowed. I think Mwebabze can.
I guess you're
unmute
already
him
allowed.
and
Yeah.
talk. Yeah.
Okay. So go ahead.
Right. Great.
So just
I have a
focus
problem,
on the
definitely.
first of these, if you don't mind.
Yeah,
The first
definitely.
question.
Mine is a complaint on the random assignment. If I come last, or if my assignment is more than the books, definitely I have a very big complaint. I'm not satisfied.
Hello.
Good. So the point is, you might be, if you come last, you're sort of stuck with whatever happened to be left over. Is that what you're saying?
Yeah. Yep.
Okay, good. And you might even say, if you go last, you're sort of getting a random book, whatever happens to be last. But I would argue in this method, even if you go first, you're also still just getting some random book that you might not care about. So I think that's a valid concern, but it might even apply even if you're not last. So, okay, so we have others raising their hands. So I just allowed,
Hello.
Yes.
Yeah.
Go ahead, whoever said hello.
Yeah.
Yep.
So for me, I don't have a problem with the random assignment of books. Yeah, it is very okay. But
why not?
But what I'll think is you select people who want a particular book, if it's for the AI or if it's for data science or any other. You put them in one pool, then from them you can give randomly that particular book. That's my thought.
Okay, so you're suggesting something that you think is better. So I guess the fact that you're suggesting something else implies that you actually do have, even though you're, happy with, a free book is a free book, it sounds like you gave these different categories. So what would happen if the way that things are done right now is the concern about not getting a book related to a category that you would want?
Yeah, exactly.
Okay, good. Yeah, so it's, you just getting some book that maybe is relevant to you and maybe it's not. Okay, so thanks a lot for contributing. So I'm unmuting. Oh, I guess I'm asking to unmute. Oh, because talking is permitted already. So Kwazi Mifembu, sorry if I'm mispronouncing your name. Do you want to speak up?
Hello, can you hear me?
Yes.
As the previous speaker said, that if maybe people could say which books they want and then you put them in the pool of the particular book that they want, and then you do a random sampling of who gets the book. I think.
Okay, great. So same sort of issue is, it sounds like the same problem you had and the same solution you're proposing as the previous person. That sounds reasonable. Great, valid concern, reasonable solution. All right, and let's see. So Shelmis,
Hi everyone. Hi.
Hello.
I think the two speakers ahead of me have already mentioned what I wanted to say, because that's what I've also put on the chat. It could be that even, and that's the same thing you said. If I was the first to receive a book and I received a book whose area I'm not interested in, it wouldn't help a lot. So again, dividing these people into certain groups based on their interest and then randomly sampling from those groups. So that's what the other two speakers have mentioned.
Excellent. Okay, great. So it sounds like there's some emerging consensus around some concerns and an idea for a solution. Let me just go through the chat here and let's see if there's any other ideas of people who said something but they don't want to or maybe are unable to speak up. So we have the clustering idea within the chat as well. Fair distribution. I won't say who said these because if they were to the panelists, just to provide some anonymity, but thank you for responding. So someone said fair distribution based on needs and members' locations. Okay, so this is introducing a new idea into the equation that maybe we should be giving these books out based on need or some practical concern based on where they're actually located. Let's see. I feel the approach to random assignment may not be cool enough, but rather require elicitation should be carried out among interest groups to know what they need, and by that, resource allocation can be made. Great. So, oh, and that was to all attendees, so that was hallelujah. So, yeah, that's a good point. So for those who sort of gave this idea of, you know, well, let's have a cluster of the AI books and the data science books, and then we'll have different people go, you know, get assigned these different, you know, books of different types. I guess implicit in that was you were going to be, at which Hallelujah is pointing out, is you have to ask some question now about who goes into what group. Or that's one way to do it, is, you know, actually ask people, are you interested in AI books or are you interested in data science books? And based on that, you could sort of come up with this partitioning of people, and then if you wanted to randomly assign the books, as some have been saying. Yep, and Nagari also said, ask what books one needs. Good. Random assignment may not be optimum. Okay. Write notes that contain the assigned numbers of each book. Ask participants to pick. So if you pick 1, you get the book assigned 1. If you pick 10, you get the book assigned 10. Okay, so this is, I think it's getting at, you know, well, let's elicit preferences. Let's ask people what books they want. Okay, great. And Alessandro, let's end with Alessandro's. Sorry if I skipped your comment in the chat, but we'll just move it along for, you know, to make sure we get through everything. So Alessandro says people can list their preferences, some ordering list, and then we can try to allocate based on them. So that's a great insight. And I think what maybe he's getting at, he or she, is that, you know, we could ask people what category of books they're interested in. We could just ask them explicitly, what book do you want? And have them list their, you know, preferences over books, maybe not even categories. Because maybe there's some, you know, I'm really interested in AI, but I already have AI, a modern approach, and I don't have, you know, a book on deep learning or something like that. Yeah, so maybe it's that I have some books and don't have others, or maybe I'm interested in some subfield of AI and not interested in some other subfield. So that's, I think, a useful insight that we're going to be using from here. Okay, so the complaints that we have typically heard people say are, yeah, so this doesn't consider what I want, right? It's just randomly giving out books, so I might get some garbage, something I already have or something that I'm not interested in. Here's another thing that you could imagine happening. If I actually, you know, we're all in the same room, this is pre-COVID, and I did randomly give all these books out to you, it seems very likely that some of you are going to be looking at your book disappointed and looking sort of enviously at your neighbor, and you actually want your neighbor's book. And it could even be the case that your neighbor is looking enviously at you. They wanted your book. You know, you wanted that computer vision book. Your neighbor wanted that natural language processing book. And so it might be very likely that you sort of find each other and say, hey, should we swap books? And you're both sort of better off for that. Point here is if my procedure for giving out books results in this sort of secondary procedure where you are all trading amongst yourselves, that's a pretty clear indication that I did something wrong, because I could have ideally just given you the books that you wanted to begin with. So those are some complaints. A benefit maybe is that it's relatively quick and easy. I didn't have to ask you anything. I just sort of reached into the bag and sort of threw a book at you. And so this isn't all bad. There's trade-offs to these different algorithms or mechanisms. Okay, and did you come up with anything better? We heard from a number of people this idea of sort of partitioning the books and asking people what category they wanted, or Alessandro said, let's just ask them what books they wanted and then try to allocate based on that. One detail that Alessandro didn't say, so Alessandro said, we can ask them for their preferences and then allocate based on those preferences. But what is fuzzy right now is how we actually allocate based on those preferences. So I think it's a compelling idea, and we just need to fill in the details a little bit. I think the other idea was fully specified. We ask people the category, and then we're randomly allocating within that category. Okay, so here's some alternative, which actually is really similar to, I think, what Alessandro said. So what I'm going to do, we'll call this choose your favorite, or we could call it, line up. So we're going to randomly order each attendee. So everyone's going to get in a line. I'll shuffle everybody around. So, you might be the first person, you might be the last person, but wherever you fall in line, I'm just going to, instead of reaching into my bag and giving you something, I'm just going to lay all the books out on the table, and you get to pick whatever you want. So choose your favorite amongst all of those that are remaining. And that's the alternative mechanism. Okay, so now we have these two different ideas. And actually, this is closer to what Alessandro said. So the question is, well, what about, maybe this is time consuming if everybody has to line up. So one way we could sort of do this by proxy is, now this is really what Alessandro was saying. Well, let's have everybody submit their preferences over books. So give me the list of what book, what's your favorite book, what's your second favorite book, and so on. Then I will sort of randomly order attendees. I'll just randomly assign everyone a number. And the way that I will decide, so who gets what book is, when we get to, I'll just choose whoever got the first number, and I will give them their favorite book that is available according to the list of preferences that they submitted. So that's sort of equivalent to having everybody line up, but I'm just sort of making the decision on behalf of everybody. And this actually has a name, this mechanism. It's called the serial dictatorship mechanism. So serial because everybody's lining up, so serially one after another. And dictatorship because at the time when it's your turn, you are the dictator. You get to say exactly what happens on that turn, meaning you get to say exactly what book you receive from all those that are remaining. Okay, so now we have these two different mechanisms that we've talked about. So there's serial dictatorship, everybody line up and you choose your favorite mechanism. And there is random assignment where everybody randomly gets a book. And the question is, which of these is better, or how is it better if you think that serial dictatorship is better? And this sort of just begs the question, what does it even mean for a mechanism to be good? And I saw some of you mentioned fairness in the chat. So, is there some notion of fairness that might be relevant? What does it actually mean to be good? Some of you mentioned I'm not getting the book that I want. So maybe, this idea of getting the book that you want has something related to goodness. I mentioned this, everybody trading books afterwards if I do things with random assignments. So maybe if that doesn't happen, maybe that's some notion of good. But this is sort of a key piece of mechanism design, is defining even what your goal is. What are you trying to accomplish with the mechanism, the algorithm the procedure that you're putting forward for people to follow. Okay, so here's one notion of goodness that is very well studied. It's called Pareto optimality. So an outcome is Pareto optimal if you can't make somebody better off without making someone else worse off. Let me, I'm gonna have to close my chat windows here. So if any of the other panelists, if someone raises their hand, maybe feel free to interject, and because I'm blinding myself to the chat for the time being. Okay, so another way of saying this Pareto optimality is, the outcome is Pareto optimal if there is no alternative outcome. So some different assignments of books to people where everybody's at least as happy as they were before, and someone is even happier than they were before. So if this cannot possibly happen, you sort of have this allocation of books to people that is in some sense locally optimal, where you can't make someone better off without making someone else worse off. That's what Pareto optimal is. So here's the question then. We have a very simple version of or a small version where we have 3 people, A, B, and C, and we have 3 books, 1, 2, and 3. And on the left-hand side there, you see the preferences that people reported. So person A likes book 1 the most, then they like book 2, then they like book 3. Person B likes book 2 the most, then book 1, then book 3. And person C likes book 3 the most, then book 2, and then book 1. And what those edges between the people and books are showing is which of the books each of these people actually received. Okay, so forget about how we actually decided who's going to get what book, but this is the outcome. Those people got those books. So A got 1, B got 2, C got book 3. And the question is this outcome Pareto optimal? And so this is a question for you to enter in the chat. Is this actually Pareto optimal? If so, why? If not, why not? And if anyone wants to raise their hand, if you want to venture a guess, feel free. We'll have a few of these. So this is a key concept in mechanism design and matching problems is Pareto optimality. So this is sort of testing if you really understand what Pareto optimal means. So I'll give you a moment to think about it. All right, so thanks for those who responded. So what we see, C is definitely not happy. Is C not happy? Well, C got book 3, and C actually liked book 3 the most. So yeah, so maybe this is confusing notation here that I'm using here because they're arrows, but these are actually meant to be greater than signs. So C thinks that 3 is a greater book than 2, which is a greater book than 1. So Sandra says that each person got their preference. That's exactly right. So A got their favorite book, right? A liked book 1 the most, and they got book 1. B liked book 2 the most, and they got book 2. C liked book 3 the most, and they got book 3. Everybody is as happy as they possibly could be, right? So there is no way that you could make someone, by some other outcome, you could make someone happier than they are right now. They've sort of have achieved maximum happiness as far as the book allocation goes. Okay, so this, in fact, it is Pareto optimal. You can't make someone better off without making someone else worse off. In fact, there's no way to make anybody better off. Everyone's happy. Good. All right, next example. So we have a slightly different outcome. So all that changed was now B is getting book 3 and C is getting book 2. So the question is, for you to answer in the chat is this outcome Pareto optimal? Not Pareto optimal, someone says. Okay, why not Pareto optimal? No, because B is getting his least favorite book. B is getting his least favorite book. This is true. Not Pareto, because it would need some trading between B and C to make them happier than now. Good. So that was Bernard who made that comment to all panelists and attendees. That's exactly right. Right. So there's some trading that B and C could do. So, right, B is getting their least favorite book. This is true. But the key piece is that there is this alternative outcome that could make everyone at least as happy, and someone is strictly better off than they were before. So you're not making anyone worse off. And what is it that would cause this to happen? Well, just the exact same allocation that we were showing to start with. So if B got book 2 and C got book 3, right, that doesn't make anybody worse off. A doesn't care if those two switch their books, and it's making both B and C better off. So that outcome is not Pareto optimal, because there is a way to make some better off without making someone else worse off. Okay, so someone in the chat says they'd like more explanation on what Pareto optimal means. So I guess we'll have maybe one more example, and this might crystallize it. Is there an adversarial case where A is happier if B gets his least favorite book? Oh, that's funny. Okay, so Ernest asked a good question. So implicit in how I've sort of shown these preferences, A is only caring about books here, about the books that A receives. You could imagine some world where it's not so simple. Maybe A and B are rivals or something like that, and actually A doesn't want B to get a book that A actually cares about what book B gets. So that is entirely possible. And if we were not thinking about books, it might be even easier to come up with some examples where that makes sense. Aside from this silly rivals example that I said. But yeah, that can definitely happen. That makes it a lot harder to express preferences, because now for A to express their preferences, person A, they don't just have to list books, but they have to list combinations they have to list an ordering over outcomes, say. So, maybe they care about, they have to say, I prefer the outcome where I get book 1 and B gets book 2 more than the outcome where I get book 1 and B gets book 3. So it just becomes, there's this combinatorial explosion in just expressing what your preferences are. But that certainly can be the case, and that leads to some problems for some Pareto optimality, for example. So that's a good question. Okay, so to go back to this, the simpler case though, where people just care about their own outcome, their own allocation of book. So let's look at one more example. So here, what I've changed is the preferences. Okay, so now person A likes book 1 the most, then book 2, then book 3, just like before. What changed here? Okay, so B and C's preferences changed. So now B also likes book 1 the most, then they like book 2, and then they like book 3, just like A. And then C, they like book 2 the most, then they like book 1, and then they like book 3 the least. So the question is this outcome Pareto optimal? So enter in the chat. So Fun Milola, good question. Can Pareto optimality still exist if anyone does not have any preference? So I think you're saying maybe if people are indifferent. So I guess there's two ways of interpreting what you're saying. So one might be if people are actually indifferent between, maybe A says, I don't really care which book I get. These all sound great. I'm indifferent between getting any of them. Yeah, then the notion of Pareto optimality can still hold. It's just, it makes it easier for the outcome to be Pareto optimal, because basically whatever you give A, there's no way to make them worse off if they're actually indifferent between everything. So that definition still applies. It's Pareto optimal if you can't make someone better off without making someone else worse off, meaning there's no alternative outcome where everyone's at least as happy and someone else is happier. Okay, so we have, someone says that it is Pareto optimal. Yes. Okay, so Bernard gave an explanation. Oh, good. So we have some differing opinions. So some say yes, some say no. So that's always fun, because now we can understand where is the difference coming from here. Okay, so Bernard says yes, because we can't get better than it is now. If A gets 1, A is getting 1, but B would have wanted 1 and vice versa, so it's Pareto. Okay, so I think you're hitting on B can't get what they, okay, so good. So I think what you're saying is it is Pareto optimal, and you're specifically looking at A and B, and you're saying, well, yeah, B prefers to get book 1, but if B gets book 1, that means A is no longer getting their first choice. So A is going to be getting worse off. So for that reason, B can't possibly improve their situation without making someone worse off. This is a great point. And so then the question is, what about C? So A is already getting what they want. B can't get something that they prefer more without making A worse off. And then C, maybe this was just obvious, C also can't be made any happier because they're already getting their favorite book. So we can't, good, as Nagiri said, we can't make anyone happier no matter the change of options. So it's Pareto optimal. Good. So Sheena asked, is it possible, oh, sorry, that was just directed to the panelists. So someone asked, is it possible for this outcome to be Pareto optimal? I don't think there's a way for everyone to get their preferences. So yes, this is Pareto optimal, in fact. The requirement for Pareto optimal is not that everybody gets their favorite thing in the world. That is like a globally optimal, I guess, if I had to call it something. But Pareto optimal just means there's no way to make someone happier without making someone else less happy. And that's what's happening here. So, A is getting exactly what they wanted. C is getting exactly what they wanted. B is not getting what they wanted. In fact, they're getting the worst possible thing. They're getting their least favorite thing. But still, there's no way to improve B's situation without making somebody worse off, right? Because either they're getting A's favorite book, making A worse off, or they're getting C's favorite book, making C worse off. So that's why this is Pareto optimal. So, right, not everyone has to get their favorite book. They just have to be getting a book such that, there is no other book that they could get without making someone worse off. Okay, so Mwebabze asked, is this allocation sequential? So this is ignoring the sequence. This is just saying, here is the outcome. And now, is this, so Pareto optimality has no notion of a sequence associated with it. It is just the outcome, the allocation of here are the people getting these particular books. Good questions. Okay, good. B and C got their preference, but so just reading a question or a comment. B and C got their preference, but not their most not their favorites. Well, C got their favorite, but D didn't. They got the alternative preference. I think B and C are not sad because they got their second preference. So B is, arguably sad, but because they got their least favorite thing, but they can't be made happier because without making someone else sad, and so, to use that term. So without making someone worse off. Okay, good. So that's the notion of Pareto optimality. So that's one notion of goodness. So now you could ask questions about these mechanisms. So, is serial dictatorship, is the outcome always Pareto optimal? And we could ask, is that random allocation? Is that always Pareto optimal? And I think we can say very clearly that the random allocation is not Pareto optimal, not always Pareto optimal, right? Because you could imagine that I just randomly give, there are two people, one wants book A, one wants book B, and just the way that I randomly gave out the books, it just so happened that each of them got what the other one wanted. And so they could trade to get better off. So random allocation is certainly not always Pareto optimal. Is serial dictatorship always Pareto optimal? So this actually, given the time, because I want to make sure that people actually are able to, get started on this little contest that we're having. So I'm going to skip over a proof here, but it will be in the slides. But actually, it turns out that this serial dictatorship outcome is always Pareto optimal. So I'm going to skip over it. But basically, what you can show is that, right, so serial dictatorship, again, you could think of it as everybody getting in line and just choosing their favorite book at that time. There is no way to make, there's no alternative outcome that makes everyone at least as happy and someone is even happier. So that would be the proof. So if you're a very quick reader, somehow you may have gotten that, but we'll just save it for another time. Okay, so let's talk about a different notion of goodness. Okay, so we've talked about two different mechanisms, random allocation and serial dictatorship. And we talked about one notion of goodness. We talked about Pareto optimality. Here's another notion of goodness. Strategy proofness is what it's called. So I've got a couple different informal definitions here. So a mechanism is strategy proof if honesty is the best policy, or strategy proof if lying about your preferences can't make you better off somehow. Okay, so in random allocation, well, there really are no preferences to be stating. So I guess that's kind of strategy proof by default. What about serial dictatorship? Is that strategy proof? So that's a question for you. Is serial dictatorship strategy proof? What do you think? So the first, if this is a confusing question, probably that just means that one of these terms didn't sink in, either serial dictatorship or strategy proof. So again, serial dictatorship is this sort of getting in line. We choose who's the dictator for the turn, and that dictator gets to choose whatever book they like most. That's serial dictatorship. And the question is it strategy proof? So is it actually in a person's best interest to state what their true preferences are? Or could they actually be better off by lying and saying, actually, in reality, they prefer book A to B, but they're going to say that they prefer book B to A, and that somehow gets them a better outcome than they would otherwise. So the question is this strategy proof? So this is a sequential allocation. So Felix says it is strategy proof. Maureen says it's strategy proof. Good. Any other opinions? We have people think strategy proof. People are all on board that this is going to be strategy proof. Well, your intuition turns out it is correct. So just to walk through the idea here. Okay, so first of all, okay, so I said it is this like get in line mechanism, but let's think about it as as Alessandro said at the beginning, where everyone's going to report their preferences, their list of most favorite book to least favorite book, and I'm going to randomly choose someone, randomly choose the ordering and give someone their favorite book that is still available. Okay, so here is a proof for why serial dictatorship is in fact strategy proof. Okay, so first of all, whatever you report, it doesn't affect the order that you get to choose your book, because I'm randomly assigning people into the first position, the second position, and so on. It has nothing to do with what preferences you report. Okay. Second, the preferences that you report, they don't affect what anyone before you actually gets, because those are just determined by their preferences. So you have no control over where you appear in the ordering, and you also have no control over what books are available at that time. You can't lie about what your favorite book is, and suddenly that causes there to be different books available on your turn. Okay, so therefore the book preferences don't affect, like I said, what books are available on your turn. And then aside from that, the serial dictatorship is giving you the best available book on your turn according to what you reported. Okay, so just by the rules of serial dictatorship, when it comes to your turn, I'm just going to look at your list of what you said was your favorite, and whatever is the most favorite of your books that is available, I'm just going to give you that book. Okay, so there's no way to, any misreporting you do can only result in you getting a book that you like less. So you maybe think you're being clever by saying that you actually prefer this other book over the one that you actually prefer. But all that's going to, potentially that book is taken and you get your favorite book by chance, or that book that you've lied and said is your favorite book actually turns out to be available and I give you that book, and it sort of just makes you worse off. So there's no any misreporting can only result in a book you like less. So that's effectively, why this is strategy proof. Therefore, there's no reason for you to be lying about what your favorite books are in serial dictatorship. Okay, so now we're going to, so we've introduced two notions, two mechanisms, serial dictatorship and random allocation. We have two notions of goodness, Pareto optimality, and strategy proofness. Now we're going to introduce one more mechanism, and we're calling it the abridged serial dictatorship. So just to be clear, this is not, so serial dictatorship is sort of a common term in the mechanism design literature. I'm just making up this term, abridged serial dictatorship. So don't use that. That will confuse people if you call it that. But just for, I think it's an intuitive definition here. So all that's going to happen here is, so we'll have, instead of listing your preferences over every book, you're only going to list your preferences over your top K favorite books. And then it works just as before. So we're randomly going to order all the attendees, and I'm going to give each attendee their favorite book amongst those that are remaining according to their preferences. But here's the other key difference. If all of their favorite books are gone, then they're not going to get anything at all. So here we're showing down below. So on serial dictatorship, you would give your full list of preferences. But now in this abridged serial dictatorship, we have this truncated list where if K equals 2, you're only going to state your top 2 preferences. Okay, so hopefully that's clear. It's exactly the same as the serial dictatorship, except you're not reporting the full list of your favorite books, and if all of your books that you've reported are gone, you're not getting anything. That's the only difference. So the question is now, is the abridged serial dictatorship strategy proof? So that's the question. Anyone have any thoughts on that? Feel free to reply in the chat if you do. Not strategy proof if it's a sequential allocation. It is sequential in the sense that we are choosing and ordering. These are all sequential. Yeah, we're choosing and ordering to be giving out the books, if that's what you mean by sequential allocation, Mwebabze. Okay, so we have seen some consensus amongst those that are reporting that it is not strategy proof. Okay, we actually have diverging opinions. Some think it is strategy proof, some think it is not. Good, so that makes it fun. Seku, oops, sorry. So someone says, you can't get a better book if you lie. So here is someone's argument that it is strategy proof. You can't get a better book if you lie. If the book you say isn't available, you don't get anything. Okay, so the way that we're going to test this is, remember at the very beginning, I said that we were going to have some little contest, and we are going to do that now. So here's your last chance if you want to join this Facebook group. So we are going to play this game of giving out books. And so I'm going to choose someone from this group to be a participant. All right, so I'll give you 10 more seconds. I'll put the group in here. All right, so that's the group to join. All right. So I am now going to randomly pick someone. All right, so those who have already joined, they get, so I'm going to pick 4 people, okay? So you can still join if you haven't. Here's the first one, is this person here, which is James. Here, I'll just write the name in the chat here. All right, so that's our first. Yes, I have not yet approved any of these requests because once I do, I won't know who actually joined, who just requested to join the group. So I'll approve the request at the end of the talk. Okay, so that's one person. Okay. So let's see if we can find James in here. This looks like. All right, James, I've allowed you to talk. Can you test your microphone? Okay, and the second person is, this is just randomly scrolling through. We have, oh, I'm building up some suspense unintentionally. I'm just trying to find there we go, the chat. Okay, the second person is that. So you two are the first participants here. So all you have to do to start is to be eligible in the next, I don't know, minute, reply in the chat, just say hi or something, because we need you to be able to submit your preferences. So while they're hopefully getting prepared, I'll explain what's going on. So first we're just going to do, we're going to actually run 2 mechanisms, serial dictatorship and the abridged serial dictatorship. So we're going to have two people, A and B. We have two books, book 1 and book 2. So book 1 is a book on writing. Book 2 is a book on getting into PhD programs. And so these are just two books that I really like. So we're going to do your choice of either an online version of this book or you know, I can physically send you the book as well. But James and El Harith, you guys are, if you don't reply to the chat, I'm going to pick some new people here because I need you to, you're going to have to specify what your preferences are. All right. Well, let's, we'll keep picking. We're going to pick a couple more people. So all I'm doing is randomly choosing some people here. So if you see your name on the list, type hello or something into the chat. There we go. All right, so Quasi's here. So we have one person. Next up, okay. Cedric Ona. So feel free to chat. I didn't say your name yet. Okay, so I'm going to just start going down the list. If I type your name, say that, oh, good. Oh, thanks. Sorry, I missed, so we have two people here. So Quasi and Cedric. So either James El Harith. Okay, James is here, good. So we have a third person. And now either El Harith or Emmanuel, whoever says hello first, or I'm going to just keep typing in people's names now. So Barbie Katz, if you're here, say so. There we go. We have our participants. Okay, so let me just make sure I got all this down. So we have Quasi is going to be person A in the first game. B is going to be Cedric. And person in game 2, A is going to be Emmanuel, and B is going to be Barbara. Okay, and if I mention your name, so, okay, so those are the first four, I think, that replied. So, all right, so what we're going to do, so first is Quasi and Cedric. So change your chat to just be the panelists, not submitting to attendees. I think both of you are doing that. Okay, so Quasi, you are person A. Cedric, you are person B. And what you're going to do is submit your preferences. So that top book is book 1, the bottom book is book 2. And so just submit your preferences in the chat, just as you as I was expressing them. So I'm giving some examples. So either you say that you prefer 1 to 2, or you say that you prefer 2 to 1. So I'll let both of you, so submit your preferences. I'll give you, say, 20 seconds to submit what your preferences are. Okay, and just to be clear, whatever book you are saying first is the book that you are preferring. That's your most preferred book. And whatever book you say second is your second favorite book. Okay, so what I'm seeing here is Gary reported 1 greater than 2, and Quasi reported 2 greater than 1. So actually this worked out really nicely. Both of them, there was no conflict. Each of them preferred a different book. And so there you go. You guys we'll get your respective books. So I'll chat with you later today, this evening. So Gary got book 1, Quasi got book 2. So great job, guys. So that was pretty boring in some ways. I mean, it's great for Nigeri and Quasi, but all they had to do was just say what their favorite books were, right? There wasn't too much, there wasn't anything complicated there. And it just so happened that they, each had a different favorite book. So, it worked out that everybody was getting what they wanted. But now let's go to this abridged serial dictatorship. And to simplify this, we are going to use money instead of books. And this is out of date, I suppose. This is from Ghana last year. So we're going to use World Remit. So I'm going to do this live. So we'll have World Remit. So I'll give you, so this will be data. So data worth, let's say, $10 USD, or alternately, you can get, let's say, $3 in data USD. You know what? Let's make it a little higher. Let's say $7 USD. Okay, so this is the abridged serial dictatorship. And so what did I say? So A is Emmanuel. B is Barbara. So Emmanuel and Barbara. First of all, just give me, make sure you're replying to panelists only. So what you're going to do, so this is going to be abridged with K equals 1. So just to be clear, what you're going to do is say what's your favorite of these is. What do you prefer? Would you rather have $10 in data, or would you rather have $7 in data? And you're just going to tell me what your favorite is. And the way that this is going to work, remember the rules of the abridged serial dictatorship, is I'm going to randomly choose one of these, either A or B to go first. In fact, I'm going to write that down now. Or you know what, I'll flip a coin. I'll flip a coin to decide whether A or B goes first. And so then whoever goes first, they get whatever they prefer most. And then whoever goes second, if what they listed is still available, they will get that. If it is not available, then they get nothing. Okay? So hopefully that's clear. So Emmanuel and Barbara, so hopefully the rules are clear to everybody. Emmanuel and Barbara, I will ask you to submit only to me. So this is option 1. So only to the panelists. Say whether you prefer option 1 or option 2. So you're sort of privately, simultaneously submitting your preference list. You know, it's only a single preference here. The list is length 1. But go ahead and do that. So this is Emmanuel. This is Barbara. And okay, so we have Barbara submitted her preferences. Emmanuel, can you submit your preferences? Okay, so remember they only got to choose a list of length 1. Emmanuel said he preferred option 1, which was $10. Barbara said she preferred option 1, which is $10 data. So now it basically comes down to the coin flip. And so heads will be Emmanuel, tails will be Barbara. I'm using a British pound here. And we have tails. So Barbara went first. So the way that the mechanism was working, so I randomly chose Barbara to go first. And I see that, so her preference was $10 in data. So I'm going to provide that for her. Then I get to Emmanuel, who went second. His preference was also $10 in data, but that is no longer available. So option 2, would have been available, but because option 1 is not available, then Emmanuel gets nothing. So hopefully that was clear that these, there was only one of each of these. Please object if the rules of that were not clear. Okay, so yes, very clear. Okay, thanks, Emmanuel. So what happened there? It seems that both of them, I assume both reported truthfully, right? It wasn't the case that someone, for some reason, preferred to have $7 data versus $10 data. But, it turns out that, Barbara probably is perfect, very happy with this outcome. I'm guessing in hindsight, Emmanuel wishes that he would have said that he preferred $7 in data. So, he prefers that he would have misreported, lied, and said, actually, I prefer $7 in data, because then he would have been better off. And like really to make this extreme, you could imagine that option 2, so let's just say option 2A, instead of writing 7, imagine that I wrote $9.99 worth of data, right? So then it maybe really becomes obvious, like, why, you might reason, well, the other person is going to say that they prefer $10. So maybe I'm, better off saying that I prefer this lesser amount. And maybe I'll at least get that, even though it's a smaller amount, I'll at least get something. Okay, so all of this is to say, so now that we've done that example, the question to you is the abridged serial dictatorship strategy proof? So feel free to respond in the chat. And note that people had to decide what their preferences were before they knew whether they would go first or second. So you had to state your preferences before you knew if you would be first. So is serial dictatorship strategy proof? Feel free to reply in the chat. Anyone? Not strategy proof. Good. Thanks, Maureen. It's not strategy proof. We have a clear example where, Emmanuel, even though they both truthfully reported, we can clearly see that it actually would have been in Emmanuel's best interest to misreport and say that he wanted a smaller amount. It's not strategy proof because one would lie just so they don't miss out. Good. That's great. Okay, great. So that is the example. So the takeaway the first takeaway is just the rules of the game matter. And 2 small changes to the rules can make a big difference, right? So those last 2 mechanisms, all that we changed was just the number of items on your preference list. And that changed, that small change to the rules went from a mechanism where it's in your best interest to truthfully report to one where actually you have to strategize and reason about, well, what is the best thing given, what do I think others are going to do and what should I do given that? And it's hard to reason about that. So yeah, those are the main takeaways. So we've covered a number of different notions of good, strategy proof, and Pareto optimality. We have covered a number of different, I've introduced you to a few different mechanisms. So random allocation, serial dictatorship, and this abridged serial dictatorship where we have these truncated lists. And I've shown that these different mechanisms have different properties. And these properties, if you care about certain properties, then that really affects, you should care about what mechanism you actually use. So a key thing here, this was a toy example of books to people, DSA attendees, but it didn't have to be that, right? The question is, can you think of other systems that you regularly participate in that are very clearly not strategy proof or that do not produce Pareto optimal outcomes? And what are some similar problems to this book giving problem? And what's a general version of that problem? So this would normally be a time for discussion. I think in the interest of time, we're going to skip this discussion, but this is sort of the key question that I'd like you to think about. Because, right, it didn't have to be books to attendees. There's an abstracted version of this. It is resources to those that need resources. This could have been, this is some version of this is how Stanford University decides what students get allocated to what dorms, what housing. This could be, some version of this is used to decide what doctors get allocated to which hospitals. But they're slightly different because now doctors have preferences over hospitals, but maybe hospitals also have preferences over doctors. This could be students to universities. Again, universities might have preferences over students. Right. So the question is, how does this pattern match in your everyday life? And can you think of any examples of this where you see some inefficiencies in the way things are working around you? And if you can, it could be that you becoming an expert in mechanism design actually allows you to solve some of those problems. And furthermore, to help support that, this is what that contest that I was describing at the beginning, those research grants, global challenges in economics and computation. If you can come up with a real world problem like this, that is exactly the kind of submission that we would like to see in this request for proposals. And indeed, the answers to some of these questions are exactly what many people submitted to that request for proposals. So to really, where I'm going to finish, and I'm going to end a little bit early just to give you some time to actually go through this exercise on your own before the next talk begins. So we're going to have a mini contest. We're not going to have a $150,000 contest right now, but we're going to have local challenges. So the goal is for you to basically answer that question. So identify a real world problem in your region that could benefit from the tools of mechanism design. So the prize is going to be a mechanism design book or a course, an online course of your choosing. So we will, find some way to, I'll give you a list of books that I think are good and some online courses that I think could be relevant. And so the winner is going to get one of these books. The deadline, so I'll give you a submission link on the next slide. But so the deadline is soon. It's the day before the last day of DSA. And so we're going to, it's just a simple Google form. feel free to submit early for feedback. You can edit your submission, and to the extent that I am able to, I'll give some feedback on what I think are compelling submissions. And we'll announce the winners, if it's okay with the DSA folks, at the end of DSA. If not actually making the announcement, then I'll send an email immediately after that to all those who submitted. So here's the forms that you'll use, and I'm reusing the same forms that we used from DSA in Ghana last year. So this is literally the same process that some of the finalists used last year to submit finalists for these $150,000 research grants. So use these forms. The first one is just meant to be, and actually, Ernest, if you don't mind while I'm talking, maybe if you can, or one of the other panelists can paste these in to make it a little bit easier for people. So the first of these is really just brainstorming for your own sake. I try to set things up, asking questions that I think will hopefully allow you to find some problems that where incentives actually do matter, or that you are sort of uniquely positioned to tackle this real world problem because you have some connections to say someone in some organization that might have a mechanism design problem. The second of these forms is where you can actually submit. It's a really simple form. You're just basically saying, what is the problem? How might the tools of mechanism design be useful? And give your name. The Facebook group, that's what some of you joined. I'll add all of you right now, those that requested to join. And so really the end goal here, I mean, yes, someone's going to get a mechanism design book or course of their choice, but really I think hopefully the benefit is I would love to see this as just as it was last year and the year before that, for these to be the seeds of some ideas for you to, if you're not already, some of you I think are already involved in this area, which is fantastic. But for those that are new, I hope this is the seeds of some ideas that get you involved in this community. If there are not people who are experts in mechanism design in your area right now, that makes you uniquely positioned. You have some area of expertise that others around you don't have. And the world looks very different once you start thinking about the incentives of those around you and how you can design systems to sort of, with those incentives in mind. So yeah, I really encourage you to submit to this, follow those links, and I will evaluate. I'll make some announcement for the winners, as I said. And yeah, I would really hope that, for those of you that are interested in being engaged in this community, like we will find people for you to work with on these projects. And if you're interested in that, or provide mentorship, whatever you need to have some compelling submissions for next year's global challenges in economics and computation. All of this started with people at DSA. Ernest gave a talk at Cornell. That led to Mwebabze attending EC one year that I was there. And that's what got me at DSA to begin with, because I know, that made me realize how many compelling problems there are around the world that our community is not touching on, and how we really need you to join this community and become an expert in your area. That helps you, that helps others near you. I would love to see you become the expert and train others in your area in mechanism design. So yeah, join these contests. We'll announce the winners at the end of this DSA workshop. Hopefully these lead into submissions for next year. Also, I encourage you to attend the Mechanism Design for Social Good talk, which I think is tomorrow. Just check the schedule. That is a great group. I'm totally unaffiliated with them, but they are doing awesome stuff. They were sort of the motivation for this contest and for me doing any of this stuff. So they're also a tremendous resource, and I encourage you to attend that talk and join their group as well. All right, so that's all I have. I have a few minutes if there are any questions. I'm happy to take them. Otherwise, thank you very much.
Great. Yeah, so let's give Eric a virtual clap somehow. So wherever you are, clap. And if you have
clap
any
for the winners that are in attendance as well. And really anyone that submitted, those that were not winners this past year, I think are super compelling submissions and are just, I really hope they turn into longer term collaborations, because there were a lot of good submissions from DSA people. So kudos to DSA for rising to the challenge.
Great. So if you have, so we still have a couple of minutes, 4 minutes. So you could ask Eric any questions if you have any questions, or just send out a shout to him, or, take a coffee and wait for the next session. Thanks a lot, Eric.
Thanks a lot, guys. Thanks for attending. Thanks to the organizers too. I'll stick around for a few minutes in case anyone has questions. And I'll approve everybody that joined the group. Shagun says, what happened to some of us that could get the data grant? Oh, yes. Yeah, so some are, so we provided data for those. Thanks for reminding me of that, Shagun. We provided data for attendees for EC, as well as the Global Challenges in Econ CS workshop. I still have to reimburse some people for day 3. I reimbursed for everything up until that. So thanks for the reminder. I'll actually do that today. But yes, everyone that applied for a data grant did receive that. All right, Bernard, I'll just send you a quick email so that you can stay in touch if you are interested in joining the group that are having trouble. All right, so I guess I'll leave you with my email address. Feel free to email me if you have any questions. Also, feel free to post in the group. I also encourage you to, if you don't get a response, it's not that I'm intentionally ignoring you. I just get flooded with emails. So just be persistent and just, ping me if you need to until you get a response. But, very happy to, if anyone has any questions, or would like any guidance, very happy to provide that. So I think that's all for me. So thanks again, everyone. Hope you have a good one.
Thanks a lot, Eric. Been great.
See you guys.
Bye. Great. So we have 1 minute, and then we'll jump into the last 2 presentations. So one is from from me on computer vision, and then the other would be from Michael, who will talk about NLP. So let's stretch our legs a bit and get started in 2 minutes. Okay. I guess we'll dive in now. So this is the computer vision lecture. I hope people can hear me. It's a bit of ambient noise on my side, but should be fine. Right, I've posted the link for the collab in the chat. So if you want to check it out, they can check it out there. Okay, so I'll begin then. So the computer vision tutorial for the summer school will be one on doing cassava disease detection, or disease detection generally. So I guess the early talks on oh, link requires access. Okay, sorry. Let me do that. Okay, so the link should be active. So when you get the link, it's viewer only. So you need to go to File and save copy to Drive, and then it will save a copy to your drive, and then that copy is the one you can edit, so that we are not all editing the same collab. Okay, so the yeah, so the earlier talks. I think you had earlier talks by Benjamin and a couple of other people on deep learning. And so this is sort of an extension to those talks. And the one way I thought I would do it was to do it as a collab that we can walk through instead of a presentation, given the time of the day. I also think it may be more useful for people to dig in. So the goal is to sort of more like Eric also said, we are going to go through this tutorial, and then at the end, the idea is for you to take it further, to take the collab a bit further and do something. There'll also be a competition and a place where you can submit your results, and there'll be prizes. The prizes. Last time we gave T-shirts. This time we may look at giving virtual e-T-shirts. So let's see how it goes. Okay, so the table of contents, what we want to cover is basically walk through computer vision, the idea behind computer vision, feature extraction, and then going to the neural networks, CNNs, talk a bit about data processing, building models, building a basic CNN, and then trying to improve that with augmentation, and furthering that with transfer learning and different ways of doing fine-tuning of models which have already been built. And then we'll sort of look at things that you could do to improve the model after that. Okay, so I hope we all have this notebook. So if you've copied it, it should be straightforward. So the link there. If you want to get some more background on computer vision and state of the art and what's happening now, there's a good presentation by Ernest, which I've put here. There's also very good courses online, so this should be easy. So one way to use this collab is to use the GPU. So if you're going to run some of these notebooks, it may help to use a GPU. And the way you do that is to go to runtime, change runtime type, and then you can select a GPU or a TPU. Or if you leave it like this, it will use a CPU. Still the same thing. If you run the cells, the first cell will probably give you an error because you don't, well, I guess my runtime reset. Okay, so you clone some repo from with some of the materials. It basically has the data for this collab, and you can sort of see the data if you want to see what you've downloaded. Okay, so some utilities and the data basically. Okay, so Colab also comes with some, you can import some of these libraries. They come already installed in most Colabs. So it's unlikely you'll get an error there. There's something about pandas, but we can go through that. So you need, I think this you did with getting started with data science. Matplotlib is for plotting. Seaborn is not too necessary here, but for making the plots look a certain way. NumPy is numeric Python classes, and then you have some utilities in this utility.py file to get images for the different classes and plot them. Okay. So what do we want to do with this in the computer vision session? We want to take a typical problem that you would want to solve in sort of a context of Africa. And I know many people have sort of worked on this problem or are probably working on similar problems. So you want to take the data that John presented, for example, the cassava data that we had. Okay, let me just share the link again. All right. Yeah, so then so you want to you want to take the problem that John had. So John described this problem. I think Joyce is here. She probably has also talked about it. So the idea is that they've been collecting data from farmers all over the country, and John was trying to plot this data, give you some understanding of the spatial spread of disease. And he was talking about one particular disease called cassava brown streak disease. So cassava is not only affected by cassava brown streak disease. You can imagine that there are several other diseases. Here we'll look at 5 or 4 key diseases. And these are the diseases. So you have cassava mosaic disease, which is sort of the CMD here. You have the healthy class. You have cassava bacterial blight, which is CBB. And then the CBSD, the cassava brown streak disease. And then cassava green mite. So you have several diseases. John only looked at plotting only one disease, which was CBSD. And so we want to see if the farmers are collecting this data. So they have an app on their phone, perhaps, that they're using to collect data. How can we build a model, a classifier that can tell whether an image of a leaf taken is diseased or not? So we do want a simple, one way to do it is make it very simple. Combine all the diseased classes as one and the healthy class as one, and then make a binary classifier that says, I see a diseased leaf and I see a healthy leaf. And then maybe you can assume the farmer could, go with a diseased leaf and maybe get a generic solution for that. But in this problem, we want to make it a bit more interesting. So we want to actually classify which disease it is that is manifested in the plant. And so with this sample data we have is about 400 something images that you download from GitHub. And if you run these commands, this basically lists the classes. Which classes do you have? The next command picks a random set of images for the classes. So when you run this on your Colab, you should get, it's likely you'll get different images. But these are just typical examples of what images are in the different classes. And so you can see for the first image, CMD, it has, it represents, the disease represents slightly differently. You can see what a healthy plant looks like, what a plant with CBB. So this is bacterial blight, what CBSD looks like, and then what a green mite looks like. And so you can see the diseased leaves look quite similar. The diseases look quite similar in some way. And so we expect that this building a simple classifier would generally be hard, or this would generally be a hard problem to do. Okay, so more generally, the goal of computer vision is recognition, more generally. And so you want to recognize something from either an image or a video. And videos, you can think of a video as a sequence of images. So the different frames that form a video You can think of them as images, and that's how they process videos. And so the most basic, perhaps common task in recognition is classification. So do a simple task of classifying, given an image, which disease is represented or manifested by this image. So given an image, you want to classify it correctly, categorize it correctly. And you can extend this to the farmer with the phone, with the app, takes an image of a leaf. He wants to know which disease of these 4 diseases or 5 classes we have that is represented. And so images, particularly in our context here in Africa, so this is DSA, images are important because they have unique properties. So because we have a multiplicity of languages, there are many languages people speak, it's hard to build an app that gives, that is very detailed in text. You know, if you have to do it, then, for example, in Uganda, where we have several hundred, well, maybe about 100 plus tribes, you have to transcribe it in all the different languages for all the different farmers. So you can think of images, makes it a bit easier. If it's an image, then it's clear. If it's, for example, an X, then you know it's a diseased image, or if it's a tick, then you know it's a healthy image, and you may classify different diseases differently. Anyway, the goal here is that images tend to be quite important. So computer vision is important, and people have done many things with computer vision here. I know people have done this with different crops, for example, beans, maize, etc. People have done this with weather. So there was a gentleman who was taking images of the sky, and from those images trying to predict whether it will rain or not. We are doing this with health data. So taking images, having a phone, having a microscope, or a way to magnify the image of a small blood slide, to magnify it and take the image of the parasites there, and do things like counting or classifying how many parasites are there. Are these white blood cells, red blood cells? So there are several instances of people doing computer vision for real world type problems. All right, so one idea is to think about how do we model this disease predictor that we want to build. And so the goal, and so I made this schematic here, which is sort of an idea of how we can think about the problem. So you take the raw data, you have images that are taken, and then from the images, you want to extract some sort of feature that represents the disease, right? And if you extract that feature, then maybe you get labeled data. So you have labeled data, which is data which is collected with an expert. So in this case, the data was labeled in 2 different ways. Part of it was collected, and then an expert, someone who is an expert in cassava diseases, takes a look at the data, and then they classify. They say this is CND, this is CVSD, this is this disease, this is the other disease. And so you have labeled data, so examples of the diseases for each of the classes. And so the idea is to train or to fit a model, to this data. And this is what we'll dwell on in this collab. And then after that, once you have your trained model, you want to do prediction. You want to use it to say, given a new image, is this diseased or not? But what you can also do with CNNs, as we'll see, is you can also if you had another way of extracting features, you could extract features, maybe not, this is slightly different from CNNs, but you can also use CNNs to extract features from images. But if there's another way you can extract features, as we'll talk about, you can extract them use them, the same model, and get a prediction. So this is a general schematic of what we want to do. Okay, so feature extraction. So this tends to be an important part when you're thinking of can this problem be solved by computer vision? So you want to, sometimes a good proxy of whether a problem is a good computer vision problem is whether an expert can visually differentiate things. For example, in this case, you have an expert who can say this is cassava mosaic disease, this is cassava green mite, and so this is a good candidate for computer vision. And so feature extraction, basically you're trying to mimic this process where the eyes of the expert see something, and we assume the eyes extract certain patterns or certain features from the image that make him, give him the ability to determine what disease it is. So how we've done this previously, or how it has been done, or how it's being done in some other areas, was to actually extract different features. So one way, I mean, you could think of maybe just by looking at these examples, for example, and the examples you have, what kind of features do you think we could extract? What would be useful features to extract from these that could represent the disease? So you can sort of answer on the chat or raise your hand. Yes, so we have Luchamzi. You can unmute yourself and talk.
Hello.
Yes,
You
Andrew.
hear me?
Yes, we hear you.
Yes, one of the features I can see the edges of those leaves, they vary.
Mm-hmm. So which edges are different, for example? I see the healthy and the CBSD, for example, the edges seem to be the same.
The smoothness.
Mm-hmm. Right. Okay. So I guess, so which class, for example, would be easily identified by the smoothness of the edge of the leaf?
CMD, is it the first one? CMD.
The first one. Yes. Okay, great. Thanks a lot, Andrew. Yeah, so the edges, you can see CMD is a bit jagged. Cedric says the color of the leaf. I see Albert saying the varied colors as well, and the texture. So you get the feeling also that the texture of the leaves may be different. Maureen talks of the size of the edges. Interesting. The color. Albert talks of non-uniform pattern. The shape, we can extract vine network within different leaves. That is very interesting. Extracting vine network. That is not something I thought about. Okay, so it seems there are several things. At least we have a heuristic of what features we'd want to extract from these images. And so we can, this begs the question, of course, then how do we extract features from these images? So the field of computer vision has grown tremendously in the last couple of years, but maybe 7 years ago, and it has had a rich history. So part of the history that that sort of spurred some of these algorithms was the creation of new algorithms, especially around the OpenCV computer vision kit. So there were new algorithms that people came up with, but also there was increase in the capacity of computers, personal computers, to do this. And the problem is that computer vision looks at pixels. So you can imagine these images here are maybe 300 by 300. So that's 300 times 300 pixels. So maybe you have 90,000 pixels. You need to look at different things related to one image. So if you have to do any computation over the pixels, then it's going to be very expensive. So if you see the OpenCV package, it was initially built using C because they needed speed of compute. And then they built Python bindings, Java bindings over that. And anyway, for a big part of the, for a good time, for a long time, computer vision was marked by things related to OpenCV and different ways, different handcrafted ways of extracting features. So people would exactly what we've said. So maybe you extract the color and you look at the color. Based on the color, you build a classifier. It could be a logistic regression or k-nearest neighbor or SVM. And you could extract things like edges using convolutions. So convolutions was still a big thing then, only they were done not as intensely as we do them now with neural networks. And so some of these were state-of-the-art techniques, had all these heuristics and thresholds that you needed to tune and parameters that you needed to fine-tune to extract features from images. And so what happened then was that a lot of the feature extraction was very tied to the problem. So you had one problem, for example, we have, in this case, leaf disease detection. So you'd come up with a unique feature extraction toolbox for this problem, because doing this would not work if you are doing things like microscopy or you are trying to detect other types of features for other types of problems. So it was very intensive. You had to build feature extraction routines for every single problem. And so you get things which were state of the art, like SIFT features, SAF, that people found to be quite robust for doing things which were near automated feature extraction. And it's interesting history. It's very good. It'd be good to read about it if you have the bandwidth. So getting these handcrafted features is a bit complicated. And so what has happened in recent years is the event of deep neural networks. And particularly for computer vision, these have been convolutional neural networks. And these provide automated ways of extracting these different features from the image. And these you can call them image representations. And why they are really, CNNs are quite important. They can extract different levels of abstraction of image representations, from simple things like edges, corners, and you can go up to different abstractions of the object, combinations of edges that form a concept. So the convolutional neural networks are quite interesting in that. And that's their major strength. And you can sort of go in and dig a bit deeper about this. So in this collab, we will not go into the depth of CNNs. I hope, I don't know if the tutorials on deep learning went into it, but for two reasons, we'll not go into this. One, there are very good courses that cover this. And two, many of these have been automated in toolboxes. So it's important that you go and look at the theory behind them. But once you've done that in this sort of tutorial, want to see how you could quickly get to using them. And so we'll use TensorFlow 2, which comes with the Keras toolbox embedded for doing this, makes things a bit simpler. Right, so so data processing. So we need to Okay, so we're going to use deep neural networks, and we're going to do this. So how do we extract features? How do we process data? So you have an image, how do we process that to a place where we can compute over it? So this requires us to extract, to format it in a way that we can compute over it, process it. And so generally, image data is formatted appropriately, is preprocessed. You want to read in, you want to get some routines for reading in images. Maybe the images are in PNG or JPEG or different compression formats. So you want to be able to decode that into component pixels. And the normal images we'll look at are RGB images. These are the most sort of common images. So they have and so we want to take these images, from them we want to extract the pixels, and want to convert this into floating point tensors, because so ordinarily the quantization of images, or the way they're compressed, they have pixels from numbers from 0 up to 255, 255 being pixels that are white and 0 being pixels that are black, and then the range of colors in between. And so you want to convert that into, normally it's advisable to convert that into a range of 0 to 1, because these convolutions deal with very small numbers, and so you want small numbers in your model for training. Also because there are many calculations that are done in a convolution in these models, and so you want smaller numbers so you can do many more computations. Generally be hard if you're considering 2 pixels of 255 intensity values. Okay. All right. So it seems so we have this idea. I want to take an image, convert it into some numbers, and numbers which represent intensities of light or intensity, and you want to put that within a range of 0 to 1. And so it may be, it can be daunting to think about doing this by hand, but it's not impossible, but there are now toolboxes that can do that. And Keras offers these, or TensorFlow offers these ways of doing this easily. All right. So if you're here, you can import TensorFlow in Colab. So it's embedded in there. You don't need to install it. And then we're using a feature of Keras, which is the image data generator. And later on, we'll see how to use different other things. So we want to generate data from folders of images. So the only way you have to prepare your images is to put different images in different folders, different classes of images in different folders. And then you can use this image data generator to extract all these images, the format that can be computed against. And so you want to rescale. So rescaling is sort of converting to the range of 0 to 1. And then you want to, I'm sure you went through a tutorial of creating different training set, a validation set, a test set. And so you can create different portions of your data. You can use this flow from directory. Basically, you're picking images from a directory. This is the directory I want to pick them from. The target size, so you can determine what size of image you want and to resize the images to that size. The batch size, you want to process them in batches, helps the training. And in our case, we want to do a classification. So we'll use categorical as the mode. So And there are many, many more parameters that you can sort of tweak in this image data generator. Cool. Okay, and then want to do the same thing for the validation set. Once you've done that, it should return different found X number of images of X number of classes. And this, so the 268 will be the training, and the 163 will be the validation. So for 5 classes, if they're uniformly balanced, a data size of 250 or 268 is a bit low. It means they're about 50 examples per class. So this is generally quite low for using neural networks, for getting the benefits of neural networks. But want to see what we can do with this in this collab. All right, so we can visualize them. Can take a batch of images. Oh, don't run something. Okay. There we go. All right, so we have now a format for data, for computing on our data, which is a batch of 16 images. They have size 224, and they have 3. This 3 represents RGB, the red, blue, and green. And we have the labels as well. So how do we build our convolutional neural network? So we build a simple model here, and the goal is to build, or I mean, you can try different model architectures. So different architectures, I'm sure as you've learned in the deep learning class, is basically stacking different types of layers on top of each other. And the goal is you take an image, pass it through these layers, and then it will generate different image representations. So this sort of passing through different layers for images is a way of extracting features. So extract edges, maybe in the first layers, and corners, and then it goes down, extract bigger things, a combination of edges and maybe different concepts and different objects. And so you can use this process, this funnel, to extract features that you can eventually apply to a dense layer, as you probably already learned, and then you can do a classification on top. Okay, so the deeper our convolutional base, the smaller the size of the feature maps. So feature maps are basically features that you extract as you continually go through the layers. So the convolutions, the 2D convolution, so we have different layers. You have a max pooling layer, you have a convolutional layer that sort of do opposite things, and then you have dense layers that you can use for immediately doing things like classification. And then you have different ways of applying regularization in this model, which I hope you covered there. So in order for it not to overfit, you may add a few dropout where it drops out some neurons from these layers randomly, and different activations in the models. Okay, so with Keras, it's very simple. You can either, so it had 3 modes. One of the modes is building sequential layers, and sequential layers are basically layers that are stacked on top of each other. Just keep stacking. The output from one layer feeds into the input of the next layer. And so they're sequential in this sense. And so we've built a simple model here. This model has no motivation. It's basically putting together a bunch of convolutional layers and max pooling, and then some dense layers at the end with some sort of regularization. So nothing special here. You can change this. You can swap out the layers, make it longer, make it shorter. These are sort of the different hacks of how you build neural networks. And so most of the part in actually building these models is trying to figure out which layers work. But now we know there are standard layers, standard models or standard architectures that you can use that seem to work really well. So one caveat is that the deeper you go, the more layers you have, the more parameters you have to compute over. And so it means it will take more compute. Luckily, if you're using a Colab, then you have a GPU that can help with the compute. But if you're using your own computer, then you may want to make sure you balance how many layers you put in there. All right, so that's our model. Our model is sort of a combination of different layers. And now we want to fit our, so if you look at this diagram here, so we have our model here. We've built our model as a CNN. So a bunch of layers that we think will filter out our images and extract features. And in order to get a trained model, we need to fit our data to our sort of this model that we've created. And so we can do this with the fit generator because we are generating images on the fly with this Keras image generator. All right. Okay, so it expects a Python generator, which will yield batches of inputs and targets. So you yield a batch of 16 images with their targets, which is what we saw here. So this is what the generator does. It keeps releasing batches of 16 images with their targets, and then these go through the convolutional layer. The CNN, there is, it trains the CNNs, the different layers, extract different features, backprop to calibrate the parameters as you're sort of training this model. So in this sense, you're fitting the data to this particular model. Okay, and you need ways of doing optimization. So there are different types of optimizers that you can use, and validation. Okay, and we'll use the RMS prop. You can use different types of optimizers. The good thing with Colab is like you can see which optimizers are available by if you type optimizers and put the full stop there, then you can actually select different types of optimizers. So these optimizers are motivated for different things, but basically they do roughly the same thing. They do some sort of stochastic gradient descent with different tweaks on how you, on the step size, the variation of the step size, and these kind of things. So one way in the assignment at the end could be to change some of these optimizers and see if this gives you better results. Okay, so once we have our model, we've compiled it into a graph. Then we can sort of fit our data to this model. So this is a model we are fitting. So initially it used to be a fit generator, but now with TensorFlow 2, you can call fit and it will take a generator all the data. You don't need to specify fit generator. Okay, so you call it, this is the way you can call it. Simply, this is your training data. So it generates batches of data. It goes through several epochs, so through the data several times, in this case 20 times. And after going through an epoch, it validates on your validation generator. So this is data, it generates images from the folders and uses those as a test set. And so if you look at the training, so you have some sort of accuracy here. So it starts at 0.18, so very long. You can see it's sort of improving. You get, 25%. You can see the validation accuracy is also improving. Well, you really want to look at the validation accuracy here. So it came from 18%, 25%, and this is just 20 epochs. So you can think maybe if we train it for longer, maybe it will sort of get better. So the tricks here, of course, when training these things, one is to figure out what the learning rate is. You can tweak that. You can also tweak things like how many epochs you want to train for. And this can give you slightly different results, or varyingly very different results. You can plot the data. So it looks, so the training looks a bit haphazard for our 20 epochs, as you can see. And so the blue curve is sort of the training accuracy, and the yellow curve is the validation accuracy. And so you can see the validation accuracy is sort of going up and down. So it doesn't look like there's much training going on here. So one, because as you say, the data is limited in a sense, but maybe there are ways of tuning the parameters that you get some training going on. And I'll leave this as an assignment. But you can see it looks like it's up and down for the different epochs, which is, so ideally you'd want it to be smooth, sort of going up. So the loss, is also important to look at the loss. It's important to look at your training or validation accuracy and the loss. So the loss ideally should be going down. We can see it takes a huge leap and then sort of flattens out. So this may give you an indication of overfitting, or the training is not going on as well as you thought. So the validation loss, for example, you see is not changing much. Of course, it could be the scale of our graph. In any case, these are sort of results from a very simple training. Okay, so there are also different ways there are more concise ways of using TensorFlow. I thought I'd put these here. So one key resource I thought I would point out is, so you have, of course, TensorFlow. It has several tutorials. It has things on images, so you can sort of walk through these tutorials as well in your free time. They also give you a high-level sort of view of how you can do different things with images. Okay. Right. So you can, these are just different ways of plotting the same thing. Here, maybe you see generally is our trend. So as you can see in this graph, it's less. So this one, the problem is that you have a very limited, the y-axis is sort of limited. Here you can see clearly that the trend is a bit, it's sort of not training, sort of just barely training. Okay, so how can we improve this? And this you typically find, as we say, the problem seems to be quite hard differentiating these images, and we have limited data. So it's unlikely we'll get good results immediately. So one way of improving this is to do data augmentation. So data augmentation is sort of increasing or varying your data more. It generates slightly more training data from existing samples. And so we want to increase our data by altering the images that we currently have. And so it does different things. It may rotate images slightly. And so you can see with data, the image data generator, this method, or this class sort of has different ways of doing this. So it allows you to add data augmentation in there. So for example, here we're saying rotation range. So rotate images. Once you pick them from the folder, rotate them by 40 degrees. Width shift range, so shift it or shear it. The height shift range, shear range, zoom range. So you can sort of zoom out the image or flip it horizontally. So converting the image on the horizontal axis. The fill mode, basically, once you've done these manipulations, how do you fill parts which are empty? For example, if you zoom out or shrink it a bit. So you can apply different, so these parameters here basically give you, they control how these augmentations are done on your image. And so by doing data augmentation, it has been shown to have significant benefits or some good benefits on, especially when you have limited data. And describe them here a bit what these things mean. All right, so let's do some augmentation and see. So here we are taking our healthy images, and you can do this for other images. We're getting some healthy images. Pick one image, and we load it. We are getting it from this data gen here. Oh, yeah, so we need to run this. So we've created a data generator, an instance of this image data generator class. And this one generates images by doing all these things based on these parameters. And so if we pick one image and pass it through this data gen and plot the 5 images that data gen, or the 5 variations that it produces, then we can sort of see what happens. So this is the same image. So if we get the same image and parse it through this data gen, so you can see this image, I don't know what the original image was, but if you look at the image 1, here it has been horizontally flipped. The second image seems to have been horizontally flipped. You can see these things at the edges. So it's been sheared or shifted a bit. These things here, it's sort of, if they were empty, it fills them with the nearest pixels. So again, this one has been shifted. This one has been flipped. So you can see the second one seems to also have been zoomed out or zoomed in actually. So from one image, we can create different types of images or different other images that we can use for training. So that's the whole point with augmentation. Okay, so maybe we train with our augmented data. And so we can take compile a different model. I don't know if this model is changed much. Different levels of filters, etc. Okay, and so we can create, so this is the same. So we are training, our training data is being augmented in this case. The test data, so we don't augment the test data. So this is one caution. So we don't want to augment the test data because the test data represents data that looks like data that will be found in the field. So if the farmer is going to be in the field taking images, you want the test data to be faithful to sort of that data. And so the data won't be sort of sheared and shifted. And so you don't want to augment the test data. And then, yeah, so test data, the validation data basically comes from the test data. Okay, so we can do that again. We can fit our model again, or train, fit our model now with this new data set, which is augmented in some ways, and see if we get better results. And so even for the 20 epochs that we are training, we are seeing now we're getting maybe some 30s, some 40% in the training accuracy and the validation accuracy for some of the epochs, but it still seems very haphazard. But we can see some high some high figures there. And we can try and plot that again. So again, you see the graph is slightly different. We see there tends to be sort of higher accuracies overall, but it still has those problems. I think it needs to be run over several epochs. etc. The training loss now seems to take a nice curve there, but we still needs a bit of work, as you can see. But generally, I guess the idea here would be that with augmentation, and maybe I'm hoping maybe we'll see this once you do this on your own, that we improve the performance of our model when we augment the data. And hopefully when you train longer, you change the learning rate, maybe you will see different, you'll see some improvement with augmentation. Okay, so those are sort of the some of the things we can do initially. So so the problem we've been trying to solve in some way has been the data problem in this case. So we're saying, okay, now we are switching the data, increasing it by augmenting the images. But we did nothing about the model or the architecture that we're using. So we came up with this architecture here, which is, generally it's a random architecture. You could remove or add some layers, but maybe there are ways we can improve the architecture. So we have to think, maybe if you built a better architecture, it can filter out better features, and those features can be more informative of your final goal of classification. And so one way to do this is to do transfer learning. So you can increase the performance, particularly in a small data set, by transferring learning, where we use features extracted from maybe another image, a larger image set or a larger model for example, in this case, for image classification that was already built, and we can transfer what was learned there. Maybe they trained for longer, trained with a bigger data set. Maybe we can transfer the initial feature extraction and then add onto this our specific goal of training a cassava data set, and maybe this will improve. And so why this works is that, so the first layers generally of a CNN in this case extract different granularity of layers, of features. So you have the first layers, they tend to extract edges, corners, and then it sort of goes getting the image representation sort of gets richer as you go down. So if you have something that has been trained on a larger data set of images, then maybe it has learned ways of extracting edges, colors much differently, or in a much better fashion. And so maybe you can take that, cut off the top, and on the top add different layers that are specific to your problem, in this case cassava disease detection. And this is what we want to do. And so things have been made relatively easy. With Keras, you can call different architectures. In this case, we are calling a MobileNet version 2 architecture. And if you highlight it, it sort of gives you more information about this architecture. So it's a MobileNet version 2 architecture. It highlights the paper. It was a 2018 paper. etc, etc, etc. You can sort of scroll through this and gives you some idea of what you need to do to apply this, this architecture. So we're taking an architecture that people have used that works, MobileNet, so it sort of works well with mobile phones in this case. It has a specific input size. We remove the top, so we're cutting off the top classification layer and adding our cassava detection layer on top, and want weights of ImageNet. So the ImageNet is the larger data set from which it was trained. And so yeah, so we can call this very easily, and it downloads weights from the Keras repo. And then we add our layer. So we have a global averaging, a pooling layer. And on top of that, we can sort of add our own type of layer. So we get our prediction layer. We get a very simple layer. We are saying five classes. We have 5 classes of disease. So we get a dense layer of those many. A very simple classifier on top, softmax. With 5 layers, we build our model. So we have the base model, which is this model from MobileNet. We have some averaging layer to average the top there, since we've cut off the top. And then we add a prediction layer to that. And basically the prediction layer should, and then we can train this with our cassava, with our data. We can fit our data to this model. Okay. So build a model. And so one idea, of course, could be that you could add several other layers here. You could add other convolutional layers here. You could add some more dense layers here. You could make it more interesting and see if it sort of works better. Okay. Now we have a different sort of feature. So again, from this base model, you actually extract features. So you can actually see what type of features you're extracting. If you wanted to extract features, this is one way to do it. You give it a batch of cassava data, and then based on whatever weights it learned from ImageNet, you can extract some features. And these features that we apply to our classifier. Okay, we average them, and then you can actually, you can see what the global average layer does. So you have, it produces a tensor, which is basically, we have a batch of 16, it just flattens it out to a 1 to 8 vector. All right. And so we can use our prediction layer. In this case, if we predict, we'll get a softmax output. And so this basically is softmax output of 16 batches. So 16, I mean, a batch of 16, so 16 images by 5. So basically it's, these are the predicted classes of all our, of these 16 images. And so this is softmax output. So I guess this would be the winning class here. It has the highest quote unquote probability, and that would be this one here. So you can see they are predicting, I don't know what class this is, this must be healthy. So this is healthy, it predicts healthy, here it predicts healthy. So it generally predicts healthy. Maybe this is an artifact of the data. So this may be something you can look at. How is the data balanced? So in this case, you can see a lot of the predictions are healthy. But from this, etc. Okay, so that's an example of how we can use a different architecture, in this case, MobileNet version 2, cut off its top. So we are cutting off the top here, and add on our cassava model as the top here, and then train that. Okay, so we can train that with our larger data set. So this was just an example with the one batch. If we take all batches, I mean, we can okay, how to fit. All right, so we can train it, train our class and see if we have any improvement, if adding a different architecture provides any type of improvement to our model. So with 10 epochs, you know, it's not clear. It's not really clear that we are doing a significantly better job. It's hard to see, but this in a sense is what you'd be trying to do. So the idea is that theoretically this should improve the model. We have a simple model. We've only added the one dense layer on top of this. Maybe we need to add some more layers to get a good model. So I'll leave this as your exercise to do. So this is one way of getting a different architecture. So the other way is to use something called TensorFlow Hub. So TensorFlow Hub has several other. So this here we're getting it from the Keras application, so Keras repo. But you can also get these models from TensorFlow Hub. And the way you do it is slightly simpler. So you can specify, again, we're getting a MobileNet version 2. We create a Keras layer from that. In this case, you're getting a feature vector, so you can specify a feature vector or a classifier. So here, the feature vector means the head has been cut off. So it's similar to what we had previously. Freeze the layers. And then you can, again, we have a very basic layer, again, just a dense layer with 5, representing our 5-class problem. We've switched the optimizer here a bit. And we can train it on our data. Okay. So we get some error. Okay, why didn't I run here? Validation steps. It's complaining about validation steps. Let's make them really small. Expected dimension of 1. Right. Okay, we can sort of work on this and figure it out. And clear what the problem is. Train call. Okay, we can work on this. But anyway, so one thing I thought you could do in the remaining time. So we have about 20 minutes remaining. So one, I thought you could take this Colab. Most of the things work. So the biggest, I guess one of the biggest things about, I think the things that consume time when building good models, one, getting the data. Once you have the data, processing it into a reliable, okay, let me just copy this link again. Well, getting the data into some reliable, processing it, this takes a bit of time, cleaning it, making sure there are no obvious errors in the data. So the next thing that takes time is actually tweaking these models. So as you can see, it's very quick to build a model. I think here we've built maybe 4 models or so with different orientations, different sort of strategies and techniques. For the last 2 models, we've been trying to improve the architecture. First one's up for improving the data. But the things that take time will be tweaking the parameters. So training, the learning rate, or maybe tweaking the optimize a bit, or in this case, how do you do, I mean, a number of epochs, how do you add, what's a good sort of top layer to add on top of a feature extractor, and this kind of thing. So for the last 20 minutes, your goal will be to sort of do this. Try these augmentations, try different epochs, try different sort of tweaking different parameters. You could try different models, different architectures on your own. You could come up with different architectures. So some of these are just they're just hand drawn architectures with not much basis. You can try different things and try and improve the accuracy of this of this little data here. Given this limited data, can we have some good accuracy? So last time people got, I think, 70s with a few tweaks, 60s. So that may be a good goal to try. So one other way of one obvious way of improving models is to, I thought I'll just add this here, is to use larger data sets. And so there's such a thing as TensorFlow data sets, where data sets are uploaded here, and there's a description of the data set. For example, we have a larger cassava data set here. It has almost 9,000 images. For this collab, we're using maybe 400 images. This one has close to 9,000 images. You can see the examples. You can see examples of what it looks like. And there are also several other images. There's one for beans, again from the AI lab. And the cassava one is from the AI lab. There are several examples. There's ImageNet. So you can sort of use some of these examples of data sets if you're training different things. And there's audio data, image classification, object detection, question answering, text. So there's several data resources you can put here. It also provides a way for you to share your data. So if you've collected data, I think it's quite good. You can do a pull request at TensorFlow datasets, and you can add your data to this list of data. Okay, so the data. So one way of improving our accuracy is to use a larger data set. So this is a data set that the AI lab provided for, the Makere AI lab provided for a competition on Kaggle. So there's a leaderboard there and etc. But you can also download this data set. See if improving, if you keep your architecture the same, you can improve it by just increasing the data set. And this data set is 1.2 gigabytes, but with on your Colab, you can easily download it in about less than a minute, and it doesn't consume your data. So these are some advantages of using Colab and of putting data sets in publicly shared places. So now you can access 1 gigabyte of data quite easily. So if you download this, you it will take less than a minute to download. You can try different things. I put some scripts here to prepare it for computation. You can augment it different ways. So you can use TensorFlow to augment, you resize it, crop it, do a random crop. Random crop basically crops out a section of the image from different places. You can change the light intensity, the brightness. You can do several other things with the image. So one way is to create an augmented data set. And so this takes advantage of this TensorFlow data toolbox or library. And if you want to know more about these optimizations, you can sort of click here and to explain more about these things. But one thing you can do with the TFDS is you can, with the TensorFlow data, is you can string different types of things to it. For example, you can take a random subset of examples. In this case, from the 9,000, we are taking maybe 2,000. You can change that sample. You can cache the data so that the algorithm doesn't take long in loading the data. You can shuffle the data. You can, well, this is a map to augment the data. So you can do functions, you can map the data. So which data you can map it to this augment function here, and the data will be augmented. The batch size, and then you can prefetch it. So prefetching helps you to, especially if you're using something like a GPU or a TPU, it prefetches different batches of data so that your processor doesn't have to wait for the data input output. So imagine if you're picking data from a file system, the amount of time it takes to do that, the processor will be idling. So prefetching makes sure that it sort of optimizes your training pipeline. Okay, so once you have, so this would be your data. So this will create a generator, Python generator, a data generator that will generate data on the fly, different batches of data. You have your validation, so you can go back and retrain it using the same routines we had up here. Okay, so the last thing is for you to put your results on. So we're having a challenge, as I said. So the idea would be for you to, so the challenge is on the first small data set, can you improve the accuracy of the small data set? And then optionally, you can also do the sort of this bigger data set. If you have time, you can try the same things with this bigger data set. And we are putting a leaderboard as well. So, well, there's a trial there. So once you run your model, you can go to this form here and submit your name if you want to be recognized and whatever accuracy you get, and we want a screenshot of your training results. So a screenshot something like this. So you can take a screenshot of this thing here and you upload it. So we don't want people to upload results which we are not sure of. And then any comments, if you change the learning rate, it's optional. And optionally, if you've tried on the larger data set, you can. And once you submit, then you should go to our leaderboard here, and then you can see out of the several people on this call who's sort of getting good results. Yeah, so I guess we can do that in the, yeah, we have about 11 minutes. So let's dig in. Okay, so that's really the end of this session. If you have any questions, you can ask. So this is unclear why this is when Okay. So for some reason I can't, I see the Q&A has some questions, but I can't access it. Maybe if there is another panelist on board, they can quickly read the question.
Yeah, thanks for a good presentation and the tutorial, Ernest. The first one says, how can you use computer vision, CNN, to determine the extent of damage or simply quantify the effects of disease in plants, and which models or approach do you recommend? It's about quantifying the disease. Yeah.
Right. So this, I guess this takes two approaches. So one is, are you quantifying disease on the leaves, or are you quantifying disease on some other output like a root or a fruit, maybe a fruit? And so there are different ways of doing this. So one way, so the simplest way is to do something like what we've done. So imagine the leaves we've shown here. You can think of. Sorry.
It's the leaves. The leaves. Yeah.
Right.
Yeah.
So the leaves. Right. So the leaves you can, and this is an issue with annotation. So at one point when we're talking with experts about annotating these images here, so the idea was, do you annotate the leaves? Yeah. So there are different ways of annotating an image such as these. So you could say this whole image represents CMD. Some papers have annotated the leaves. So you actually delineate the leaves. You get the leaves out and leave the background out. And so you can say these leaves represent cassava mosaic disease. Alternatively, you could sort of highlight these yellow areas. So these patches of leaves. And so that's different ways you can annotate this data, and which gives you different ways of analyzing it. So the simplest way is to do what we've done. Say this whole leaf is CMD, and then you assume that the architecture you're using, the CNN you're building, will actually internally identify these areas where disease is, and use that in the classification. And there are different tools to actually see what exactly your model is finding as the most relevant thing in an image. That's one. So the second is to do a segmentation, to do image segmentation. So if you've annotated this very well, and you've identified where the disease is, for example, where this disease is, then you can do an image segmentation. So you can add a different model on top of, even you can extract different features and add a different model on top of that to do image segmentation. And in this case, it would be trying to segment out what it thinks as the foreground and then the background. So to try and, given the annotated image, to try and segment out, build a model for segmenting out where the disease is. And then based on this segmentation, then you could try to infer disease. And then there, maybe you can also run maybe a different classifier on top of that. So the problem or the challenge here is what exactly you're trying to do. When we try to do this with the farmers here, for example, in Uganda, and ask the experts what would be most meaningful, they said what is most meaningful is the farmer just wants to know, given a leaf, what disease it is. They're not too keen to know exactly which portion of the leaf is diseased. That's one aspect. The second aspect was, how do you do good annotation? So if you take this image for CGM, the last image in this example, how do you annotate it so well that you annotate the disease spots? So here the disease represents as spots of yellow on the leaf. So this would be hard to do a segmentation over. And so this would be tricky with leaves. And so those are the different considerations that that fall into the thing. So I think the most important thing is one, utility. What are you building this for? That should determine how you annotate the data and what types of models you build. Yeah.
Yeah. Thanks a lot, Ernest. The second question from Andrew says, what do you have? Are there any techniques on selecting the appropriate pre-trained model for adoption?
Yeah. So one rule of thumb, of course, is these models take a lot of resources and space, so memory. And so you have to determine which type of model you want to, based on, in some part, based on what you want to, where you want to deploy the model. So you have different ways of thinking about, so you have large capacity networks. Large capacity architectures that you can use, and this may be good in some sense, but this may be constrained if you think of deploying this to a mobile phone. So for example, in this case, we use MobileNet version 2 because it has better performance. It's a newer model than MobileNet version 1. It's now MobileNet version 3. And it has been shown it has certain optimizations that are good for deployment on a mobile phone. So here the case was clear because we are thinking of a use case of deploying to farmers. If you think of deploying to maybe a server, then maybe you want a large architectural, a model with a large architecture. But then also you have to think of inference time. So how much time does it take to actually do inference of this model? And so this may determine what sort of architectures you use. So one way to, a good way to compare these things is, I know, for example, Google has released this thing called Task Adaptation Framework, which is an open source thing where you can call different architectures for the same problem, and you can call different data sets. And so you can try different combinations of data sets, architectures, fine tuning with different sort of base models, and then you can see which works best for your particular problem, and then you can sort of use that for your deployment. But the general rule of thumb is basically, it'd be good to try several of them, constrained by your deployment characteristics, and then select one. So that's what takes a long time to actually build things that can be deployed in real life. Cool. Was there another question, Dina?
No, I think this is it, unless people are going to ask more questions. And thanks a lot for the answers. Yeah. Cool. Yeah. And the competition. Mm-hmm.
Yeah, we're waiting to see which, how the competition fares. Okay.
There was one more asking about the images that you displayed earlier showed some leaves that were adversely affected by a disease. Can this model be used to detect a disease at its earliest stages before it becomes visible to the human eye?
Right. So there's two answers to that. One is separately, we've tried to collect data that may not be visible to the human eye. So we've tried to collect spectral data. So spectral data, if you shine light through the leaf, then you can measure how much light is absorbed on the other side, or how much light is reflected from the leaf. And this gives you some idea of the internal metabolism in the leaf. And this is the hypothesis we're using. So the atoms or the different molecules in the leaf are affected by the metabolism. And disease in a leaf, for example, affects the metabolism. So how the plant manufactures food. And so if you shine light and it's reflected differently, then you get spectral data, wavelength and intensity of light emitted or light absorbed. And then you can build a model using that data. So what we found is that this can work. Actually, it works quite well. And I think this is work from Godliver. And I think she found that you can detect disease before it's symptomatic, maybe, I forget the days, maybe 10 days before it's symptomatic, something like that. So if you Google Godliver, Omgisha, you'll find that she has some results for this. So that's one. The second is, can this model be used for that, given images which are where the signs have not been seen? So there's a hypothesis that this can work. And why this hypothesis stands is that if you think of some of the adversarial computer vision papers where, and this has been done with ImageNet, where the classifier is trained, is a little bit of noise is added to the classifier so that it classifies dogs as cats. So you'd look at an image of a dog, but when it's given to the classifier, they have added subtle noise that is not visible to human eyes, but the network can detect this noise. And if they tune the noise fairly well enough, they can convince the model that this image of a dog is a cat. So they're very interesting papers on this. You can look at sort of these adversarial computer vision papers. So if you infer from that, you can think that if a model can detect this level of noise, which is not visible to human eyes, maybe it can, maybe you can have the same model detect certain features of the disease before they are visible, before we can actually see them. So we may look at a healthy leaf like this and think this is healthy, but maybe the model can infer certain other things that we can't necessarily see that could be related to disease. So this is a hypothesis that it's something on my mind. It hasn't been tried. I don't think it has been tried, because in order to do this, you need an experimental setup that that enables you to have a ground truth. And this is where the complication is. But that's a hypothesis. So theoretically, I think you could, but it's yet to be tried. Yeah, it's the, okay. So we are, it's 4 o'clock. So I think we'll let the next speaker come on. So yeah, so that's the end of the session. So The next session is by Michael, who is not yet here. So in the meantime, can I suggest that if you have the bandwidth, you can go through that notebook and we upload any results. There are prizes for the winner. We'll get an e-t-shirt, I think. That was the prize. Wait for Michael. Michael will give a talk on NLP. Okay, I think we're trying to contact Michael, the next speaker for NLP. He's not yet with us, so we'll give it a couple of other minutes, I think. So yeah, so we've been waiting for Michael, and it seems Michael is unfortunately caught in circumstances that don't allow him to present, to do the workshop. So what we're going to do, I think, is we are going to end early today. So we'll end 39 minutes early, and we'll encourage participants to do those notebooks. So there was one from John, the spatial analysis. There was one from Charles in the morning. He had several other exercises there on Gaussian processes. And there's the latest on computer vision. It would be interesting if you can go through the computer vision one and try and improve the accuracy. You can also compare your accuracy if you do the final data set with that on Kaggle. And that should be an interesting way to fill these 35 minutes now. Okay, so I've been told you have the links for tomorrow's session, so it will start on time tomorrow. So if there are no burning questions from participants, then we'll close this in 1 minute. Okay, so less burning questions, cold questions. Okay, we've gone through the whole list of questions. Okay, so we'll wrap this up here. So thank you, all of you who have attended, and see you tomorrow. Thank the presenters for today, John Quinn, and Charles, and Eric, and all the rest. Thank you, and goodbye. See you tomorrow.
Thanks. Bye, everyone.